Next is the mesh mode. In the previous version, one can check the mesh quality only after performing analysis. Thus, every time one wants to check the mesh quality, the analysis should be performed again, which is inconvenient and time-consuming. The newly introduced mesh mode provides the ability to check and modify the mesh size and shape. Besides, mesh creation errors in the pre-processing stage can be detected without analysis. If you run the mesh view mode, you can check the mesh shape immediately. First of all, there is a setting dialog in mesh view mode that allows you to control the overall mesh size. Here, you can set the mesh size separately for each part and determine the mesh shape. The mesh shape is categorized by the triangular and square shapes. Each model can be composed of only triangular elements or a mixture of quadrilateral and triangular elements. Next is the mesh size control function. This is a function for controlling the local mesh size. The first icon is used for the mesh size of the edge in 1D member or 2D member. And the next icon can control the mesh size of a 2D face by a member unit. Information of mesh size is saved in the tree as shown on the right and can be edited. Finally, check mesh result. This is the function that finds errors occurred in the created mesh before performing the analysis. The first option finds the cases where the mesh is created without taking into account the interference between two members. The first figure shows that the two members' meshes did not interfere with each other, and the information of the two members is provided in the check result table. The figure on the right is the case with the regular mesh shape created with considering interference. The third option finds the abnormally longish element. As you know, if the element has a longish shape, we cannot get the exact result in FEM. To find the longish shape, we should enter max threshold value. The element's threshold value is the ratio of the square of the perimeter to the area multiplied by 4 pi. For example, in rectangular element, when the aspect ratio is 1:1, then the threshold value is 1.27. And when the aspect ratio is 100:1, then the threshold value is 32.47. In triangular element, when the aspect is 1:25, then the threshold value is calculated as 16.57. The check mesh result box shows the element 21 since the ratio is larger than the set maximum threshold value of 20. I will demonstrate the mesh view mode through the sample model. At this time, the mesh of the model was created to have errors in purpose. If I check the displacement shape in the analysis result, I can visually confirm a problem in the connection. To pinpoint element with problems, execute the check mesh result. When I click the list, the program flashes element as shown on the screen, so the location is easily detected. In a large percentage of this case, the problem is caused by modeling, so that modifying the model will be the solution. After modifying the model, I can confirm that the deformation shape becomes normal. When performing the mesh control again, we can check that there is no errors on the table. And let's create various mesh shapes using mesh size control. I am going to change the size of the mesh. When you click Auto Mesh, then you can see how the mesh is created. Since we used the small mesh size, the mesh becomes compact. For 2D face, I'm doing the same procedure. Then we can check the mesh becomes compact again for 2D face. First, we will do the size control for the edge of 1D and 2D members. Next is the control of the 2D face. Even if a large size is entered as input, the created mesh size may be smaller than we want, since the adjacent element also affects the creation of the nodes simultaneously. Let's edit it again with a minimal value. In general, the smaller the mesh size is, the more accurate results can be obtained. Therefore, applying the smaller size only in the necessary part can reduce analysis and design time.